Go ahead.
Hello, welcome to this talk about Freertos. Let's first take the legal part. This is distributed by Creative Commons share alike, which means you can reuse it partially or completely as long as you keep this license intact. So who am I? My name is Attila, and I've been doing embedded software consulting for a few years, and I'm currently working for a company called Mind. So after this commercial break, let's see our agenda. I'll give you a brief introduction of what is basically Freertos. I'll talk a little bit about real-time basics. Then I'll talk about Freertos configuration. We'll talk about its API and give a small talk about the flavors of Freertos and its licensing. So Freertos is a pretty lightweight operating system. It's designed to run on microcontrollers, and well, just the operating system itself takes 5 to 10 kilobytes in flash and about 300 bytes on the RAM. It does support some memory protection if your CPU core supports it, but it doesn't do any address translation, so no TLBs. It does put the tasks in absolute priorities, which means a higher priority task always preempts a lower priority task. Even preemption is optional, so you can slim it down pretty small sizes. And all the configuration is done by a C header. It's basically, as I will show ahead, it's a bunch of defining some symbols. So why would I use this operating system? Because now currently we have pretty powerful microcontrollers, like a chip I'm familiar with is Atmel SAM4, runs at 120 megahertz. That's pretty much faster than my first PC. So with that much power, you can handle a lot. And as long as you want to do multiple things with a single chip computer, you will want to schedule them, prioritize them. You need to communicate between your tasks, and you will need to synchronize them. So it boils down to, I have a very powerful single chip computer, so why not use a good operating system on that? Let's talk about real-time systems. I'm assuming you at least have a basic concept of what a real-time system is. Basically, whatever tasks you are handling, they have deadlines, and you need to meet those deadlines. The timing is critical. And meeting deadlines means scheduling your tasks in a smart way that each deadline can be met, well, in time. So you need to manage your priorities. And one way of managing those priorities is deciding which task is more important and which task is less important, and scheduling it that way, so that you basically say some of the tasks, it's okay if they miss their deadline, and some of tasks are critical, so let's keep them always in the highest priority. Or if you are familiar with the academics, you know the most optimal way of managing deadlines is doing your scheduling, your priorities deadline-based, if you know your computation times and your deadlines. And all in all, to achieve these, you need your system to be predictable. So A Freertos or no piece of tool, no piece of software can turn a system into real time. You need to design your system to be in real time. And what Freertos does is basically give you the facilities to make your system predictable so that you can design it in a real-time way. It gives tasks absolute priorities so that you know if a higher priority task can run, it will run. You can be sure of that. And obviously, it gives you some timing facilities so that you can delay tasks or fire them in a repetitive and predictable way. And as any basic operating system, it gives messaging queues and semaphores and mutexes so that tasks can communicate and synchronize. And a small note, all this operating system has been ported to many pieces of hardware, many microcontrollers. Basically, each port, hardware-specific file is a single C file, and it exists in its own directory. If I'll have time in the end, I'll show you that. So this is a summary of features of free operating system, free real-time operating system. It can run preemptive or cooperative. The tasks priority management is flexible, so that if you are into that, you can change priorities of the tasks. Also, there is priority inheritance mechanism to prevent priority inversions. There are messaging queues. There are binary or counting semaphores. There are even recursive semaphores. There are mutexes. There are also several hook functions, which makes it convenient to run separate code in certain conditions, like tick hook runs at every clock tick, and idle hook runs repetitively as long as the CPU is idle. It also has a mechanism for checking for and preventing stack overflows. And also, if you need tracing, you can add additional hooks for tracing. So this is how we configure. Basically, there's a file called freertosconfig.h, and you keep defining symbols. You enable preemption or not. You can enable or disable several hooks if you need. Then, well, we have some numerical parameters like how long a task's name can be. Then, if I want to use tracing, if I want to use mutexes, and so on and so on. So this is what a minimal main function looks like in the hardware I use with, mainly in Atmel microcontrollers. The sysclock init and board init are completely microcontroller functions. They have nothing to do with FreeRTOS. And the only FreeRTOS related function here is task start scheduler. Until I run the scheduler, there is nothing about FreeRTOS, and once I start the scheduler, it all runs, starts running in FreeRTOS context. Well, a scheduler without any tasks is nothing. So using this prototype, I can add some tasks. A task is basically a void function, which ideally has an infinite loop inside. And then I register my task by calling the task create function with a pointer to my function, with a string name, a stack size. So stack sizes are fixed. That's how it can check for stack overflows. I can pass a parameter. I can pass a priority, an integer. Then if I need, I can keep a handle to my task if I need to kill the task or play with its priority in the future. Here it's null because most of the time you don't need that. And then you start the scheduler. So I said we have several hooks. These are some example hooks available. They are normally defined as weak symbols, so if you need to use them, you can redefine them, or you can compile them out. Application idle hook, as I said before, runs whenever the processor is idle. A tick hook is at clock tick. A malloc failed is, well, obviously runs whenever a malloc fails. A stack overflow hook runs whenever a stack overflows. And you see I get a handle to task and even the string to the a string parameter to the task name, so I can immediately do something about which task has been overflowing its stack. We have a semaphore API. Basically, you create a binary semaphore, you give and take them. Something important about interrupts is that a lot of API functions have their from ISR variants. Like here, I have X semaphore give and X semaphore give from ISR. If I'm running from within an interrupt service routine, I need to use the from ISR routines so that it doesn't mess with context switching. Also, messaging queues have their variants with send, receive, and from ISR. An important part of the API is delaying. Basically, there are two functions. One is the simple delay. You call it function, and your task gets delayed a number of ticks you pass. And there is a smart function called delay until, where it takes two parameters, previous wake time and some increment. And as I'll show you now, it's smart in a way that it automatically increments its own previous wake up time. And it increments the previous wake up time in a way that the task always calls periodically. So I hope this is readable. Yes, it is. This is what a task function looks like. Basically, I should have called the frequency actually period. So I have a wake up period, I get a last wake time, and then I start an infinite loop where I call task delay until, see that I don't do any manual updating, and then I code my whatever task functionality is. And here's a demonstration of how it keeps the tasks periodic. The bottom is the purple line visible? Slightly. Okay, I should have picked better colors. The purple task shows that it's a basic LED switching task. So it's active only on the transitions. And if you look at the top green line, it shows a high priority task which takes the CPU and holds the CPU as long as the green line is high. And as long as it's low, the task is idle. So what I want to show here you is whenever the green line is up, the CPU is busy with a high priority task. The switching at the purple function is delayed. It arrives late because it has a lower priority. But even then, even if it misses some deadlines, the next deadline still keeps periodic. So the wake up time updates in a way that's not the actual time it wakes up, but actually when it was supposed to wake up. This way you get some jitter, but overall in a long period, the amount of firings is constant. So we have several flavors. Let me talk about the license of Freertos. The main Freertos license is so-called modified GPL. They have a modified GPL because all the tasks, all the application-specific code gets statically linked into Freertos. So according to GPL, everything must be re-released on GPL. So they modified in a way that you can statically link your application code Freertos and still keep the application codes to whatever license you pick. So modified GPL is technically not GPL at all, but the spirit of the license is the same. So if you do any changes on Freertos, any additions, you need to re-release on the same license. But if you are just adding your application-specific code and statically linking it, the application-specific code can be kept secret or proprietary or whatever license you like. There is not a flavor, but an addition called Freertos Plus, which adds some bells and whistles like UDP support, command line processing, and some convenient I/O functions, which is available as source, but if you want to use it commercially, you can buy a license from the supporting company. Also, if you need to make proprietary changes to operating system itself, you can buy a license to ironically named OpenRTOS so that you can keep your code closed. Also, there's a flavor called SafeRTOS from the same company. This is if you are working with things like automotive where you need safety, they give support for safety licensing and safety certification. So this is mainly what I have to say about free real-time operating system. I can take your questions. Yes? Least powerful system? I don't know. Yeah, I haven't checked. But basically, I think if you have a half kilobyte of SRAM and say 10, 20 kilobytes of flash, you can run it. Its CPU, this CPU taking part is pretty small. It's basically a bunch of functions and a scheduler. So if you have enough flash and enough RAM to fit your code, I'm pretty sure it will run. Anything else? Yes?
Considering the various flavors of Freertos, does that mean when you submit patches that you have to sign over copyright?
So you're asking if I need to contribute back, I need to sign patches. Sorry, can you repeat?
You have to sign over your copyright. To folks in the organization or like
yes, since they are, well, yes, you need to sign off your patches because they are basically, they have a dual licensing model. So yes, if you want it to be included in the mainline, you need to sign off your copyright. Sorry? Heap support, yes. It's so asking if there is any heap support. As far as I know, if you enable the heap support, it does allocate a certain parts in the RAM. There, it can give you parts from the heap. So, as far as I know, I'm not completely sure of that, but as far as I know, it pre-allocates a piece for using for the heap. Yes? How does it compare to other free operating systems? I don't have much experience with others. I know that there are some operating systems like ECOS and Artems. They have more features and have more higher level APIs. What I know about Freertos is this is one of the most minimal systems you can find. As a concrete comparison, I can't really give an answer. I'm not that much familiar with that. Yes?
You mentioned the last license model with safety certificates.
Yes?
Do you know which certificates they have?
Which safety certificates they have? I don't know which certificates they support, but at their FreeRtos homepage, they do list which certificates, which ISO standards they conform to. But I did not work with FreeRtos myself, so I can't tell them on top of my head. Anything else? Yes? So you're asking for a real-world application example. Well, in one of my projects, I was working for an interface, a control interface for vehicle cabins. A single microcontroller was responsible for scanning sensors, scanning a keypad, driving LEDs, and also driving some haptic feedback, so that there must be a task to control haptic and visual feedback if you want to especially keep complex and nice looking patterns. At the same time, you need to keep scanning your sensors, and at the same time, you need to listen to keypad events and also listen to the network. If I really want to, I can write them in a huge loop with interconnected spaghetti, but I found it very convenient to write each task as a separate loop and synchronize them with queues or mutexes when necessary. So, hope that's a satisfying answer. Yes? Sorry, repeat. Debugging, yes. I can only, so you ask what tools are available for debugging. Freertos gives some hooks, some facilities for tracing. And I'm familiar with a few commercial tools from Atmel that if you use their official development tools, they have a tracing utility that you can log events into the RAM and download them via serial debug wire or JTAG. Also, there are some monitor applications that, again, using serial wire or JTAG, you can pause your CPU, and at that moment, you can dump statistics like running processes, the state of message queues, the state of each mutex, and information about tasks like how much stack they are using and if they are running or blocked or in whatever condition. Okay, thank you for your time. Thank you for listening. We have to finish here.